Hello again, our most valued student. My name is Confident and welcome to AgroLearn 24-minute lesson. Our lesson today is a continuation on the previous lesson that we did on exponents. So in other ways, this is the part 2 of exponents. I'll make it exponents part 2. As we continue under exponents as sets and logarithms, we'll look at sets and then we'll look at logarithms in the other modules or in the other videos. Let us continue and look at the exponents as we did them in the previous lesson. Now, we're given a problem to say a b squared times 4 times a squared b cubed squared divided by a cubed b times a b4. So if I can write this, you are given a b squared times 4 times a squared b cubed to the power 2 all over a to the power 3 b times a b to the power 4 equal to. Again, if I still remind you, whenever you have got a bracket like this one, if you see a bracket like this one, it means this particular 4 is affecting b squared and it is affecting a. And if you see a alone, it means there is a 1 that is invisible there. So how do you write that one? You will write it as a to the power 1 times 4 and b to the power 2 times 4 times, same thing with the 2 there, it's a to the power 2 times 2, b to the power 3 times 2, using the same method, divided by a to the power 3, b to the power 1, as you can see b alone there, it means to the power 1, times, also here it means invisible, there is a1 and b1 there, so it will become a to the power 1 times 4 and b to the power 1 times 4. If you continue to simplify that, a to the power 1 times 4, you will have a to the power 4 b to the power 8 times a to the power 4 b to the power 6 all over a to the power 3 b to the power 1 times a to the power 4 b to the power 4. Continue working on that. Now you can actually get your final answer with just minimal steps. I'm going to remind you of the 2 laws. Remember, if I can put a square here, bracket, now remembering of the laws of logarithms, if you have got a to the power m times a to the power n, it is equal to a to the power m plus n. When the bases are the same and you are multiplying, then you are going to add the exponents. Also, a to the power m divided or over a to the power n is equal to a to the power m minus n. Whenever you see a division sign, you minus, remember that. If you see a division sign, it's minus. Now, with that in mind, look at this a to the power 4 multiplied by a to the power 4 is the first law, and then divided by a to the power divided by a to the power 3 and a to the power 4 is second law. So what does it mean? This is same as a to the power 4, the top one, plus 4, the top one, they are multiplying. Divided means minus 3, below again minus 4. After that, I'll write b. Let me try to make my writing smaller because I need to fit everything. I said a to the power 4 plus 4 minus 3 minus 4. B again, you do the same with b, it's 8 plus 6 minus 1 minus 4, which is equal to a to the power 4 plus 4 minus 3 minus 4. This is same as a to the power 1 b to the power 8 plus 6 minus 1 minus 4. This is, I think, b to the power of 9. Then that's your final answer. Again, this is the simpler, faster way of using the laws strategically. Remember, with exponents, you can make your life even more difficult if you don't apply the laws carefully, or you can make your life even more easier. Another way of doing it, you could have said, okay, I want to do it differently. I'm going to open this box here. Doing it differently, you're going to focus only on the top, whereby you're going to have a to the power 4. You add only the top things, 4 plus 4, b to the power 8 plus 6, all over a to the power, you add the bottom one again, 3 plus 4, b to the power 1 plus 4. But I want to show you that this will be the same, because you're going to have a to the power 8, b to the power 14 over a to the power 7, b to the power 5. Then you need to take it on top. It will be 8 minus 7, which is a 1, and 14 minus 5, which is a 9. It will still get you to this particular answer, but in a slightly longer route. Now let us move on again using the laws strategically. You are given that problem, a to the power 6x, b to the power x, dot. When you see a dot, it's multiplying a to the power minus x, dot b to the power minus 6x, all over a b to the power of 0. Now, when you're given this kind of a problem again, the most important thing is to carefully study it and see which laws apply and everything. For now, if I can look at this, this is same base, this is same base. They are all dot and dot. It means they are multiplying, so I can use the first law of where they multiply, they add. So I'll have a to the power 6x plus minus x, 6x plus minus x. Again, b, I'm looking at the top, b again is the same. If you can look at this, base is the same. So I'm going to add the exponents because they're multiplying. It's x plus minus 6x, all over anything to the power of 0. You can see a and b are all to the power of 0 is all over 1. Then remember, any number to the power of 0 is a 1. So a, b, 0, it becomes a 1. Now when I add the top, I will have a to the power 6x. The negative is always powerful over a positive. So plus or minus x is same as 6x minus x, dot b x minus 6x. Then it becomes a to the power 5x, b to the power minus 5x. If they say leave your answers with positive exponents, if they say leave your answer in positive exponents, this question can continue from here. You are going to have a to the power 5x. Remember, you have got minus, is b to the power minus 5x. To remove that minus 5x is same as saying over b to the power 5x. Now you write b without the negative. This is the way that this negative can be removed. So it's a to the power 5x over b to the power 5x. This is leaving your answer with positive exponents. Alright, the next question that we're having here is say simplify 2 to the power minus 1 plus 3 to the power negative 1. So here we are given, if I use my red one, 2 to the power minus 1 plus 3 to the power minus 1. Now we're introducing a positive and a negative. Remember, this type of a question, don't make a mistake. NB, I'll write it on top. NB, 3 to the power x plus 3 to the power y is not equal to 3 to the power x. Either you say x times y, or you say or you say 3 to the power x plus y. These are wrong use of laws. this is not correct. A big no. Please apply the laws accordingly. For you to apply one of the law here, they were supposed to be first thing a what? A multiplication sign. The bases are the same, then the correct one is the one below. So don't put a positive and say now they must either multiply or what. This is the correct use of the law. Now when you're given that problem, back to our problem, 2 to the power minus 1 plus 3 to the power minus 1 over 2, you can see the power of 2 is affecting everything, but how do you get rid of these two negatives? If you still remember, this is same as 1 over 2 plus 1 over 3 squared. That's how you get rid of these negatives. When you do that, then you're going to say equal to, what is 1 over 2 plus 1 over 3? The common denominator there is a 6 over 2 into 6 is 3 plus 1 plus 3 into 6 is 2 plus 1. Why am I doing this? You could have said, why don't you use a calculator? Because they said without using a calculator. Now when I've done that, remember my old bracket, there is a 2 there. What is 3 times 1 is 3 plus 2 over 6, but there is still a square outside there. With 3 plus 2, which is 5 over 6, but there is still a square there, which is equal to 5 squared over 6 squared. What is 5 squared? Is 25 over 6 squared is 36. Then to prove that you are correct, go and punch this question in your calculator. It must give you 25 over 6. Let us move on and look at another version of simplifying these exponents. A very interesting one in the examiner, sometimes they bring them in the exam. They are giving you 7 to the power 2x plus 1 minus 7 to the power 2x minus 1 all over 7 to the power 2x minus 1. Now, there is a most common mistake some people do. They'll say, oh, already there is 7 2x minus 1 here and the 2x minus 1 here, then they cancel that. This is wrong method. Please don't do that method. Okay, now what must you do instead? You are given 7 to the power 2x plus 1 minus 7 to the power 2x minus 1 all over 7 to the power 2x minus 1. You use what we call split method. What do I mean? You are going to use law 1 to your advantage. Law 1. What does law 1 says? Law 1 says a to the power m times a to the power n is equal to a to the power m plus n. Let me write it from this direction going this direction. It will be a to the power m plus n is equal to, it becomes a to the power m times a to the power n. Now, because there was a plus sign, it becomes 2 multiplying. Because it was this base, they become 2 bases. So is this law now written reverse? Meaning, if I can get something like this, 7 to the power 2x, okay, 7 to the power, let me start it from a comfortable splitting. 7 to the power m plus n is equal to 7 to the power m using the same law times 7 to the power n. Are you seeing what's happening? Now, it means also 7 to the power 2x plus 1 will follow the same route as 7 to the power 2x times 7 to the power of 1. Do you see now how we can split all that? Now, using this all together now, I'm going to rewrite this question and solve it now completely. So now when they give you that, using that split method we did, this means on top there you'll have 7 to the power 2x times 7. Sometimes let me avoid using times. Usually in exponents use dot 7 to the power 1, dot is same as times, plus 7 to the power 2x, and dot 7 to the power minus 1, all over 7 to the power 2x, and dot 7 to the power minus 1. This is the split method I was talking about. This is equal to, now look carefully, you will see that you have now 7 to x, 7 to x, 7 to x, and you also have a plus sign. So what do? You factorize. You factorize 7 to x. So when you factorize 7 to x out, you take 7 to x out. Look what you're going to have. You're going to have inside 7 to the power 1, that's what is remaining, plus 7 to the power minus 1, close it, over 7 to x dot 7 negative 1, which is equal to, we don't have to factorize at the bottom because it's just one thing. But the good part now is we can now cancel that 7 to the power 2x. We are left with numbers which is 7 to the power 1 plus 7 to the power negative 1. Remember, on our using our laws again, it's 1 over 7 over 1 over 7. Then this becomes, well, let me check the question. Did they say without using a calculator? They never say don't use a calculator. You can now use a calculator to solve this and get a final answer. Then you're going to get, it's better to do the top first, use a calculator to solve the top first, and then the bottom. Even if they say don't use a calculator, sometimes it's clever to solve your answer strategically. On top, I'm getting 50 over 7 divided by 1 over 7, which is equal to 1 over 7 is the one at the bottom here, which is equal to 50 over 7 times 7 over 1. And you can see the answer there is 50. So somehow I used my calculator in a clever way, and I can prove that I didn't use a calculator, and I can get my answers correct. Now let's look at the other method where we have to simplify also exponents. What are we given here? So here, this is the scenario we're given that particular question, as you can see it. Now I'm going to do my working on this side, and then I'll just plug in the finalized simplified versions on my left side. But remember, this will be all in your answer sheet. Don't write these workings on a rough piece of paper because you might get penalized. So what we have? Well, 2 to the power n minus 1 is already done. We can leave it like that. Now the aim here also, let me tell you my thoughts, what I'm thinking about this, so that you'll understand why I do what I do. Now we see that the smallest base is 2, which means by studying them carefully, you can see that I can write 4 in terms of 2, I can write 16 in terms of 2. So I can actually express everything to base 2. Why? In exponents, the trick or the best thing to do is always to put things in the same base or similar bases. Then you can apply the laws, because the laws are based on the assumption that the bases must be the same. So now, looking at this one, we have got 4 to the power n plus 1. This is same as, remember, 4 is 2 squared. But look how I'm going to write n plus 1. Now you put a bracket, 2 squared, then you've got n plus 1. Do you see how I'm putting it? Now this is same as 2. This n plus 1 is like you've got a 2 in a bracket, then you've got n plus 1, which is equal to 2. 2 times n, it's 2n plus 2. Don't say just 2n plus 1 because you are opening that bracket. Another one I can simplify further is 16n plus 1. Again, the trick there is to understand that 16 is 2 to the power 4. Look what I'm doing there, and I also say n plus 1. I'm using the laws of exponents. When the exponents are like that, they are multiplying each other, which is 2, 4n plus 1, which is equal to 2, 4n plus 4. So with this, I can now write it as final by saying this is the same as 2 to the power n minus 1 times 2 to the power 2n plus 2 times 2 to the power n all over 2 to the power 4n plus 4. This is equal to, well, you can go on and use the split method, it's still fine in this case, but because everything is times, we're not going to factorize now in this case. What you can simply do is apply the law once. You can take everything out to the top because there is no plus sign between the numbers. What am I saying? There is a times there, there is a times there. If there was a plus sign in here, then we could have started to factorize, but there is no additional subtraction. If there is no additional subtraction, you can straight away use the law whereby you write 2 is the same as, remember they are multiplying, so it's like you're saying n minus 1 plus 2n plus 2 plus n. I'm adding the top. Now the bottom one, when it goes on top, is a negative sign, it's minus 4n. Individually again, the other one when it goes on top is minus 4. Then this is same as 2. You collect the like terms. Now it's n plus 2n plus n minus 4n minus 1, the numbers now, plus 2 minus 4. This is 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I think I wrote everything correct. Now when you simplify that because of space, which is 2 to the power, what am I having? It's n plus 2n is 3n plus n is 4n. 4n minus 4n, it's a 0. So here you're going to have 0n, and then minus 1 plus 2, which is a 1, positive 1. 1 minus 4, it's 1 minus 4 is equal to minus 2. Or here, yeah, let me just use my calculator to verify. You know, there's always a trick with the negative, and the answer will be minus 3. So it's 2 to the power negative 3. If they say I leave my answer with in positive exponent, it will be 1 over 2 to the power 3. This is same as 1 over 2 to the power 3 is 1 over 8. That then will become the final answer. Again, remember, the trick of exponents is always to make them to your advantage. Some, when they take it from this stage, just want to show you, they can take it from this stage in a different route. Some can approach it in a different route whereby they are going to say, okay, this one, they split it to, when you split it, this is what you'll get. So when you split it, you're going to have this kind of scenario. Again, after that, you can now start to collect the top and try to solve the top. When you solve the top, you'll have 2 to the power n plus 2n. You see that? Plus n dot 2 to the power minus 1 plus 2. That is the top over 2 to the power 4n dot 2 to the power 4. Then after that, you are going to have 2n plus n plus n. You are going to have 2 to the power 4n dot 2 to the power 1 over 2 to the power 4n dot 2 to the power 4. Then these can cancel now. You are going to have 2 to the power 1 over 2 to the power 4. There is one of them. Then you are going to have 1 over 2 to the power 3. Which is equal to 1 over 8. Now this is another approach. Now we have come to the end of our lesson. Thank you again. See you in the next lesson as we continue on exponents.